This is the Team PiDrogen Technical and Artistic Merit video. This is our robot. It's completely designed in Fusion 360 and is all 3D printed. In this configuration, it's got the big wheels on it ready for the obstacle course. So it has an articulated back axle, and with these wheels it has good ground clearance, and the underside is completely smooth. So this makes it good at obstacle clearance. In the obstacle video, we go up steps which are 45 millimeters high and up slopes of more than 40 degrees. The base robot that you see here has some sensors all fitted on it. It has time of flight sensors facing sideways and forwards. It has a camera on there, which is the primary source of navigation for the robot when it's autonomous. Inside there's an IMU as well, so it can measure its orientation in the world. On the back we have a control system, a control screen, so we can set the different modes for the robot and press start and stop buttons there. The robot like this has got no configuration for the various games. Instead we've got a flat top with mounting holes fitted. Within the mounting holes there's captive nuts, so you can screw implements down on top of the robot and then plug them in. There's an electrical interface for the implements here, so the robot is game independent effectively. We can use it radio control as well. There's a radio receiver in here, and this is the controller we use. This is from a drone, so it's a bit of an overkill for the robot, but it worked well in 2019. Here's a couple of images to show the width of the robot, which is 220 millimeters with the largest tyres on, and the length is 250 millimeters. Here the robot's configured for tidy up the toys. Small wheels are fitted because this is an autonomous, we play the game autonomously. We also play where you stack the bricks. I'll show you lifting the bricks in a sec. This is basically a lift. I can put the boxes in. Here I'm using radio control, but the game is played autonomously. So that's the lifting all three boxes. The camera can see underneath the bottom box, so it can pick up two boxes, drive to another box, place the boxes down and pick up all three. This is our game module for Feed the Fish. It's a rubber band powered catapult. We fire all 5 balls at once so that to minimize the time playing the game, and it's very easy to load the system. We just literally click that down. You can set the tension in the rubber bands by turning this, so we can make adjustments to how much power goes into the shot, and you can set the trajectory of the shot by unscrewing this, adjusting these 2 screws and moving this part around the arc. And you can see there's a buffer here which stops the arm, so if it stops it down low, the balls fly high but not very far forwards. If you shift this whole assembly around to this end, the arm moves much further, and the balls go further but with less height. And we found that a lot of height, close to, is what was required to play the game. I can show you it firing. I'll tell you what I'll do. I'll press the button on here. This will fire it. This is a representation of the software that runs on PiDrogen. This section here is designed to run on the robot. It takes a video feed from here, processes the images and works out what the robot's going to do. There is an IP interface onto it, and there can be a connection here either via Wi-Fi or via a wire. And then this piece of software runs on the laptop or on a PC. The idea is that the images from the robot can be seen on the screen, but also recorded to a video file. And the clever bit about the whole system is you can then take that video file, put it back into this software here, and this time run this software on a PC. And this enables you to develop the software on a PC using, still with an IP interface, as you can see here, talking to localhost, develop the software, and then when you're ready, put it onto the robot. So it makes development of software very quick.